Hey guys, Ben Pearson, the Roadster Tracker, and today I want to talk to you about one of the possible missions that SpaceX's Starship could help to execute. And that is the goal of asteroid mining. So we're going to talk about why you might want to do this, what you might want to be looking for in mining asteroids out there, and generally speaking, what the future of this will lie. So let's dive down into the subject. So the first thing is why might we want to be doing this? Well, we can mine these minerals that are out there. You can do things like make rocket fuel. You can make metallic structures like a space station or a larger ship. You can use this to return to the Earth for very, very little thrust that you send out there. And generally speaking, it's a really, really cool thing. Any mission to Mars that has any reasonable chance of success involves mining and using the atmosphere there to help produce rocket fuel, which will allow it to get back to Earth for much, much less mass sent. And because you only get a small fraction of the mass sent to another body, then it will greatly reduce the mission. A direct to Mars approach could be done in 2 or 3 missions that are carrying, say, 100 tons or more. Whereas a vehicle to, say, go there and then come back without using in situ resources would take maybe a dozen different missions because you have to take so much more fuel. You're launching all of these missions just to do extended fuel. So it's a really, really complicated thing, but made much simpler with in situ resource utilization. This concept was popularized by Robert Zubrin with the case for Mars, and it is a part of SpaceX's plans to getting humans to the surface of the planet Mars. Making the rocket fuel to get home will be an important piece. So that's in general why, and asteroids in particular have a lot of very valuable resources that make them uniquely available. First of all, they're easier to get to than sometimes even the moon, and definitely easier to get to than Mars. By get to the moon, I mean down to the surface and back up. It will take more time to get to an asteroid and back than the moon, but it may take less energy, which makes it a very, very viable thing. It's theoretically possible that an Orion spacecraft could go and visit an asteroid and come back with just the same standard SLS approach that it uses to get to the moon, and it cannot land on the moon. So it'd be pretty cool if that could happen. I don't think there's any plans for it. There is a few possible asteroids out there that could fit under there, and we'll talk a little bit more about those later on. So generally speaking, there are 3 main categories of asteroids. There's C-type, S-type, and M-type. The M-type are metallics. They consist largely of iron and other platinum things. They're really, really valuable in terms of Earth. They're the ones that get the most attention. And if your goal is to bring back resources to Earth to profit, then that may be a very good idea. But most of the benefit one would gain from mining asteroids will be in making resources in space. After all, a pound of iron isn't worth that much on Earth, but worth in space, it's worth much, much more just because it's so hard to get to. And especially if we want to build something, say, around the moon, much, much easier to bring it from outside of the system than it would be to bring it from Earth. The next valuable in terms of their resources is the S-type. S-type has a lot of metal. It still has some volatile stuff, but the S kind of stands for stony. There's silicates and other things that are in there. It does have a lot of metal. Silicates are obviously useful for things like glass and semiconductors and solar panels. They're largely kind of similar to the composition of the moon, though, although they have more water than the moon, so they have some value there. And the third type is C-type, which, depending on who you ask, is either chondrite or carbonaceous. These ones are the most common ones that are out there, although they're mostly in the outer part of the asteroid belt, not the inner part. The S-type is more common in the inner type, and the reason being is they have a lot more volatiles, and the volatiles have tended to burn out when they're coming closer in. And so they don't have as much water and ammonia and nitrogen and stuff that will bake out pretty easily when you get close to the sun. So they have different values, each one's of these. The earlier missions, quite frankly, rocket fuel is the most valuable thing that we will be needing in space. If we had a lot more rocket fuel, you could refuel a Starship and you could take it anywhere you wanted to. That is the primary thing that makes going to Mars much, much cheaper, is to use the atmosphere to help manufacture the fuel. So that will be an early subject, no doubt, for the asteroid mining. As we start to want to build space stations out there, obviously the metals and the silicates become more valuable. One other thing worthy of some note is, how does this compare to the moon? Well, the moon, it's easier to get to in terms of the time, although it takes more energy to get to the surface of the moon. And there are some neat concepts. I recently read the book series Delta V by Daniel Suarez, and the second follow-on, Critical Mass, and they talk about this system of basically making an EM launcher where they have pellets of regolith. Regolith primarily consists of alumina and silica, some magnesium, and a lot of oxygen. Most of the stuff on there is effectively rusted. So you could compress these into a pellet, you could shoot them up, and you'll have oxygen for days and days and days, all the oxygen you could possibly want, if you can get this in there and if you can bake the oxygen out. Then once you're able to do that, you'll have the metal stock to build a larger space station. You could theoretically shoot these from the surface of the moon at the right spot and basically shoot them at the Lagrange point, the Earth-Moon to Lagrange point, where you could have a small spacecraft go out there and capture these, and you would have a ton of resources which could help to really, really bootstrap an economy. Kind of a fun thing here on Earth, our moon could be one of our greatest resources. We have seen recently that Blue Origin has demonstrated that you can take the regolith of the moon. They took a simulant because the actual regolith is basically priceless. You couldn't do that, but they have a reasonably made simulant that they were able to convert into solar cells. Now, it took a lot of energy to do this, but if you can make solar cells on the moon, you can do that. And if you could launch the same regolith into orbit, you could make massive solar cells in orbit around the Earth and the moon, which could be used to power the Earth, for instance. Lots and lots of possibilities out there if you can do that. One other thing of note, the moon has a trace amounts of helium-3, which can be used for fusion. So that fuel could be stored off and shipped down to Earth for use in fusion plants. We haven't quite demonstrated energy positive systems using this, but the easiest ways to do that are when we're using helium-3. In short, the C-type are probably best for the earlier missions. The M-types will be best for the short-term gain and of money from Earth, and also the long-term building of space stations. But they all have value, and the moon also can produce a significant value, although it does not have any real volatiles to speak of. And also you would have to bake all of those out before you compress this sludge together to fire off it as a pellet if you were going to use an EM launcher. So it's probably not really practical. But they all have their place, and they all have a lot that we can learn from them. So how would we do this? And this is the great debate in terms of things. How do you actually mine this and get something valuable? As I've previously mentioned, I think the best use for these asteroids is in space to make larger space stations and other things like that, that you can only really do if you have the mass on orbit. I think mining the C-type early on to help make fuel. Fuel can also be used as a radiation shelter, which is really, really important if you're going to spend a lot of time in deep space. There's a couple of different philosophies as to what you could do. The most common ones are either manufacturing directly on the site or bringing back the materials raw or processed to a manufacturing facility that's somewhere else, be it on the Earth or in space. And they all have their benefits. If you're manufacturing, then you have to send a lot more equipment. And it's possible we could do some sort of 3D printing type exercise out there that may make it easier. And it's probably easier to do that if you're in zero gravity. So there is a lot of value to that, but it still would take a significant amount of work. Bringing them to a centralized manufacturing facility is probably better in the earlier term. You could take a relatively small asteroid and basically put it in a big giant bag, and you could carry it off. You may be able to bake out the volatiles from there fairly easily. Really, if you have it in an airtight bag and you heat it just a little bit, then it's going to start to melt the water, and you can just let that evaporate out and capture that very carefully. And using the water and ammonia and nitrogen and other stuff like that, then you can make rocket fuel. And that rocket fuel could be used to take the asteroid even closer. So lots of cool possibilities with that. The more advanced manufacturing will probably require some kind of dedicated manufacturing facility, which will be closer to Earth, because it's a lot easier to maintain. And you don't really want to send humans out to the outer parts of the solar system for an extended period of time. It can be very dangerous. You will want to use the water to help protect the humans against radiation so you don't get some sort of cancer or something like that. But it's something to definitely be concerned about. So a few other miscellaneous things. If you took a 100-ton metal chunk where 5% of it was some sort of platinum metals, and you threw it towards Earth, it would actually probably survive intact. You'd have mostly iron and nickel and cobalt and stuff like that that's not particularly valuable. But if there's 5% that's in the platinum group of rare earth metals, then you could actually get some significant things from that. And by doing this, if you could make $100 million from it, then, which is entirely possible, then that's definitely money. And if you can figure out a way to, recoup your investment on there, then $100 million profit, it only costs a little bit to do, wouldn't be too bad of a thing. We could start with some smaller asteroids, and there's a lot of small asteroids that we know about that would take less than 500 meters per second of delta V, which is a very, very low number, for us to send a spacecraft out there, capture them, and return them to Earth. These are small enough that you could gain considerable resources, and to me, this seems like the logical thing, to capture one of these in a bag, bring it closer to Earth, and use it for some kind of manufacturing. The early Constellation program that was what became the Artemis program, one of the goals was to do just that. Well, first they were going to visit an asteroid, and then they decided, why don't we bring the asteroid here to near Earth space so that we can make some use out of it. So when is this going to happen? Well, we have Starship that really, really opens up the possibilities, because if you can get 100 tons to low Earth orbit on a regular basis for even $10 million, that is a game changer. And that will allow us a lot of possibilities. There has been at least one company that has set forward. I actually applied to work for them when they very first were opening. I was looking to move at that point in time, and it was like 10 years ago. Little more than that, named Planetary Resources. Their idea was to send out some spacecraft to go monitor these, then send out more spacecraft to begin to harvest them. And it was a really neat idea. They seem to have pivoted a little bit to blockchain in space, which maybe it has some utility, and I'm sure those, cryptocurrency enthusiasts are going to comment against that. I personally don't see that it can be used in all of those purposes, but time will tell. Anyways, it's really exciting to see, and I really look forward to this. I have long been considering doing some sort of enhanced activity and like making a game or improved website or something, and making a game that uses asteroid mining as a key mechanic, a key goal. not the kind of cheesy ones. The ones that are out there tend to be you're firing a spacecraft and you go fire and it blows up into smaller pieces and you can go capture those pieces and use them to build things. That's not that realistic and not that interesting to me. But having something where you can control and see the rapid expansion that will be possible when we are able to expand into space and to start using resources will be really exciting. Let me know if you guys are interested in that, and maybe I'll actually put some real work into it. Thanks guys for everything. I appreciate all you guys do, and until next time, keep on trekking. Take care. We'll see you then.